All right, good morning, year 11s. Today we're going to be talking about we're doing a video on concentration, and hopefully this will help you learn how to calculate the number of moles of something, the volume of something, or the concentration of something in various questions. Right, so concentration is defined as the amount of solute per volume of solvent, right? So that's the definition of concentration. If that makes sense, like it's how much you've got dissolved within that particular volume of whatever you're dissolving it in. Most commonly used concentration in chemistry is moles per liter, right? So moles, we've dealt with moles before, and liters is obviously 1,000 mils, or the unit of volume. Okay, so this is the equation that we're going to deal with. Concentration in moles per liter is equal to the number of moles of substance in moles over the volume of a substance, or the solution, in liters. Okay, so that's equal to C is equal to N divided by V, as shown here. Okay, this can be rearranged to be N is equal to C times V, and it can also be arranged to be V is equal to N divided by C. Other units that you can deal with is grams per liter and parts per million, but we'll be dealing with these ones later on. Just a couple of things before we head on to the questions. Really important to read the question carefully about what ion or substance it is asking you to solve, because the ratio of ions in a substance is or can be different. Okay, so Na2CO3, for every 1 unit of Na2CO3, there are 2 units of Na plus ions and 1 unit of CO3 2 minus ions. And we'll see as we go through the questions what we mean by that. Okay, so attached somewhere to this video, or somewhere wherever the video was, is a whole bunch of questions. All the answers are there in italics after each question. You just have to get there. All right, so we're going to start off with a couple of those questions. We're going to start off with question number 1. All right, and so question number 1 is, let's go find out. What is that question number 1? All right, question number 1. Stupid camera. Determine the number of moles of HCl in 2 liters of 0.2 moles per liter hydrochloric acid. All right, so this is asking for the number of moles of HCl, which means it's the complete substance, which means we don't need to take into account the number of ions. So we're just going to do this the old-fashioned way, the easy way. Right, so we're looking for the number of moles of HCl, and it's very important to show that what we're solving. And it's important to show the equation that we're going to use. And we're going to remember N is equal to C times V. All right, so it's C times V. What is the concentration? The concentration was 0.2 moles per liter, and it was in 2 liters. 0.2 times 2 is 0.4 moles. Okay, so it's very important for you to write out what you're solving, the equation, substitute the information, and then solve it. All right, nice and easy. Let's have a look at question number 2. Question number 2, determine the number of moles of hydroxide ions in 30 mils of 0.5 moles per liter calcium hydroxide solution. So this is our first little bit of a trick. It's asking for the number of moles of hydroxide ions in a solution of calcium hydroxide. Now, you should know what the formula for calcium hydroxide is. Hopefully you know that it is Ca bracket OH bracket 2 as the formula for calcium hydroxide. All right, again, write out our equation. N is equal to Cv. What's our concentration? 0.5. What's our volume? Now, our volume has to be in liters. The question gives it in mils. 30 mils. So what is 30 mils in liters? 0.03. So important to always convert your volume into liters. What does that give us? 0.015 moles. Okay. So, is that done? No. We are asking for the number of moles of OH minus ions. Now, the number of moles of OH minus ions is related to the number of moles of calcium hydroxide ions, or solution. What is the ratio going to be? For every 1 unit of this, there's going to be 2 units of the OH minus, which means it's going to be 0.03 mole. Okay, so you must read the question. What am I looking for? I'm looking for the number of moles of OH minus. But what am I given? I'm giving the information about calcium hydroxide. So I have to take the information of calcium hydroxide and turn it into information about the hydroxide. All right? Let's do the next one. Okay, so for other questions, numbers 3 to 6 are all about determine the number of moles of something, so it gives you an opportunity for you to practice those questions. But we're going to go to question number 8. Determine the concentration of sodium hydroxide in a solution if 28 grams of sodium hydroxide is dissolved in 2 liters of water. So again, we've got the concentration of sodium hydroxide, so we don't have to worry about which ion is it and is there an ion ratio. Right? So let's go and solve this. We're looking for the number of moles of sodium hydroxide. What's the formula for sodium hydroxide? NaOH. Okay? However, we're looking for concentration of sodium hydroxide. However, we are only given information of the mass of sodium hydroxide dissolved in a certain volume. So we have to take that mass and turn it into a number of moles, because we know that at the end of it, we want to work out the concentration of sodium hydroxide, which will be equal to N over V. We have V, we don't have N. So we need to solve for N. So how are we going to do this? What's the formula for this? Little m over big M. That's going to be 28 grams over the molar mass of sodium hydroxide, which is 39.998 grams per mole, which then happens to be 0.7 moles. Okay, so 0.7 moles. Now we can substitute this one into here, 0.7. What's the volume? Again, the volume is 2 liters, which gives us 0.35 moles. What's the unit? Moles per liter. Right? So that's working out concentration. Sometimes you're not given the N and the V. Sometimes you're given other information like mass, and then you have to solve for it. Okay? So ultimately, when you're asked for concentration, you need to get to N, you need to get to V. Right? But sometimes they're going to be a few more steps to work out. All right? Let's go look at the next question. So that was question number 8. Question numbers 9, 10, 11, and 12, no, just 9, 10, and 11, are about concentration questions. Okay, so please make sure that you're looking. Look, this one here, number 11, concentration of nickel ions. The number 10, concentration of sodium ions. Question number 9, lithium ions. So it's asking for different things, and you need to sometimes take into account the ratio of ions. And you would have to take that ratio into account when you're working with the number of moles of things. All right? So let's do number 12. All right, let's do number 12, which is our new question. Determine the volume of 0.4 mole per liter solution of calcium chloride required to have 2.8 moles of chloride ions. Okay, so what volume do you need to get a certain number of moles if you've got a certain concentration of your calcium chloride? Okay, well, now what is it asking for? It's asking for 2.8 moles of chloride ions. Not asking for calcium chloride, it's asking for chloride ions. So let's work this out. All right? So, first of all, you need to recognize that, all right, how much calcium chloride do I actually need to get the right number of chloride ions? Okay, so I need to get 2.8 moles of chloride ions. If I have 2.8 moles of chloride ions, I need number of moles of chloride ions is equal to 2.8 moles. Right? How many moles of calcium chloride do I need? So let's have a think. The number of moles of calcium chloride will be related to the number of moles of chloride ions. What? times 1/2. Because for every two of these chloride ions, there's one calcium chloride, which means I only need 1.4 moles of calcium chloride, right? I only need 1.4 moles of calcium chloride. So this is what I'm talking about. Read the question. You need 2.8 moles of chloride ions. You've got calcium chloride, so therefore you're going to need to apply a ratio of the ions in it. Then, now we need to work out what volume of calcium chloride do I need. Again, I got to write out the formula. V is equal to N on C. Substitute in the number of moles, 1.4, over the concentration, which happens to be 0.4 moles per liter, and I get 3.5 liters. All right? So, take into account the ion that you're looking for, or the volume that you've got or you're looking for, and then working out the ratio of the ions to the whole ionic substance. All right? Something to think about. Let's have a go at another. All right, we're going to, again, so number 12 to number 15 is all about determining the volume of something. All right, some of them get a little bit harder, but you just have to use your brain to work it out. All right, remember when you're working out volume of something, you need to end up with a number of moles of something and the concentration. That's where you're trying to end up at, right? Once you can get those two, then you can work out the volume. Anyway, let's go look at question number 16. So now we're going back to another concept that we've dealt with before, limiting reagents, okay? But now instead of using masses like we've done before, we're going to be using concentrations. So determine the limiting reagent when 30 mils of barium hydroxide of 0.5 mole per liter of barium hydroxide is added to 20 mils of 0.4 moles per liter phosphoric acid. Now hopefully you should know phosphoric acid is H3PO4, but it is given to you, and it forms water and barium phosphate. Right? Let's have a look at the question. I have 30 mils of 0.5 mole per liter barium hydroxide and 20 mils of 0.4 mole per liter phosphoric acid. The question said that when you add these two together, you make barium phosphate and water. What is the formula for barium phosphate? Ba3 bracket PO4 bracket 2. Right? Now we've got that. Can we move on? No, we've got to balance the equation. To balance the equation, let's go bariums, 3 on that side, 1 on that side, 3. Phosphates, 2 on that side, 1 on this side, 2. Right? 3 hydroxides, 3 hydrogen sets. We're going to have 6 here. Right? So, that's the balanced equation. Right? First step of the limiting reagent is to what? Work out the number of moles of both of the reactants that you have. So the number of moles of Ba bracket OH bracket 2 is equal to CV 0.5 times 0.03. Remember to convert the mils into liters, which is equal to 0.015 mole. The number of moles of H3PO4 is equal to CV, which is equal to 0.4 times 0.02, which happens to be 0.008 moles. Do we just say the smallest one is the limiting reagent? No, we have to take into account the stoichiometric ratio. We have to work out the number of moles of one of them needed. So I'm just going to pick the first one, barium hydroxide, needed. So I'm annotating my things now. Right? The number of moles needed will be equal to the number of moles of phosphoric acid times the molar ratio, which happens to be 3 on 2, which will be equal to 0.012 moles. So now I can compare the number of moles of barium hydroxide needed compared to the number of moles of barium hydroxide that I have. Which one is larger? This one or this one here? This one here, the number of moles that I have is larger. So therefore, I have more barium hydroxide than I need. Therefore, the other substance, the H3PO4, is the limiting reagent. All right? So we've answered question number 16. H3PO4 is the limiting reagent. The next question is related. Determine the concentration of the excess reagent in question 16. All right? So the excess reagent. What's the excess reagent? It's the barium hydroxide, because we have more than we need. So let's work out how much we have more than we need, and let's work out the concentration of the excess. So to work out the excess, you need to recognize that the amount that is excess is equal to the number of moles that you start with, initial, subtract the number of moles of barium hydroxide used. Now, which ones we're looking for this one? Do we have the initial? Yes, we do. Do we have the number of barium hydroxide used? We may have, but just in case we worked out the limiting reagent with the phosphoric acid, we're going to do it again. The number of moles of Ba bracket OH bracket 2 is used will be equal to the number of moles of the H3PO4, which is the limiting reagent, times 3 on 2, which happens to be 0.012 moles. Now we can go back to our first equation. The initial, 0.15, subtract 0.12, which will be equal to 0.003 moles. Okay, so we're taking this number, and what we are going to do with it, we're going to work out the concentration of barium hydroxide left, excess. Are we actually working out barium hydroxide or hydroxide ions? Let's have a check. Determine the concentration of the excess reagent. We're just going to assume that it's the whole thing. Right? So, if we are working out the excess, I need to write out my equation, N on V. So this is my number of moles, but what is my volume? Let's have a think. Back in this question here, we added 30 mils of this to 20 mils of this. So the final volume of the solution is not going to be 30 mils or 20 mils. It's going to be what they are together. So the final volume will be 50 mils. 50 mils, represented in liters, is that. Therefore, I have 0.06 moles per liter. All right? And that's how you do question number 16 or 17. All right, now let's go back to the questions. 18 and 19 are very similar, and question 20 is about a percentage purity. So hopefully you remember how to do those. So all of the answers are attached to this worksheet. Please make sure that you are go through them and actually give them a go, and then if you don't get them right, we're going to have an opportunity next week to work through them and find out where you went wrong. Please really read. What are you working on? Are you working out the concentration of nickel ions? Are you working out the volume of, or you need magnesium nitrate, or do you need chloride ions, or do you need sodium ions? Please read that and apply that molar ratio some point in your calculation. All right? So I want you to do these ones, and then we'll go through them in class. But if you need any more help, that's where you'll see me. All right? That's all.